Thanks, Matt. As Matt said, my name is Michael Ripperger. I work at Southwest Research Institute. Kind of filling the shoes of Levi Armstrong now, so I'm excited to be here. And I'm going to talk a little bit today about some technical updates for some of the stuff that's new that we've worked on this past year. Some sort of thoughts about ROS-I, ROS-II migration, some usability improvements that we've made over this past year to some of our tools, and just some ideas for some things that we're interested in sort of working on and improving for this next year. Yeah, so starting with some new updates, we've been doing some work on our Descartes Light Planner. So I think some of you guys are familiar with Descartes, but it's our motion planner for sort of toolpath motion generation. So we've got sort of a Descartes version 2.0 that we're calling Descartes Light that lives out on Swery Robotics GitHub, but we've sort of reintroduced some different graph search algorithms there. So we run into a lot of problems where Descartes eats up all of our RAM, all of our memory, and so we were trying to find out and experiment with different ways of constructing these problems to reduce memory usage. So we've added a lot of these algorithms in as sort of an improvement there. And we've also added some different sort of search capabilities as well to be able to generate sort of non-optimal seed trajectories for some of our other planners like TraJob. And so we're still playing around with that and experimenting with this new format. And so Matt's sort of been pushing us a little bit as well to sort of take this version 2.0 and replace the existing Descartes, so reintroduce the movement interface for it as well. So I think that's some stuff that we'll be working on in the near future. So some more sort of perception related stuff. We demoed this here at Automate, but we've been working a lot on our surface reconstruction pipeline. So Tyler Marr at Swery has done a lot of work here, sort of creating a generation 2 of our YAC algorithm that we're calling industrial reconstruction. So it's essentially just a way of aggregating a lot of sensor data to reconstruct surfaces quickly and accurately. And so this has worked really well for really reflective and highly specular parts. So this has been a really huge improvement for us for generating surfaces and doing this whole scan and plan sort of idea. And so it integrates color data as well. And so we get these really nice colorized smooth meshes back and use those for toolpath planning and collision-aware motion planning as well. So we're pushing this to a new repository in the ROS-Industrial Organization. Got the link here. I don't think it actually exists yet, so give it a week or so. We'll push out those changes and yeah, definitely go check it out. So I also put some notable tools here. This reconstruction pipeline is leveraging tools out of Open3D that's supported by Intel. So that's been a huge library that we've been really leveraging in a lot of the work that we do. So I sort of want to raise some awareness about it, that, hey, this is a great library for doing point cloud and surface mesh processing. We also have started playing around a little bit more with Cloud Compare, another library for doing work with perception and point clouds. And so there's source code available, but we also built a Debian that we put out on our ROS Industrial PPA. So you go out there and download the Debians and play around with those. So they've been some really helpful and useful tools for some of the perception work that we've been doing. Sort of along the lines of motion planning, we've done a little bit of work sort of extending our planners into what we're calling meta planning. So we have a lot of tasks, sort of like scan and plan right, where we want to generate waypoints on a surface and have the robot do some sort of surface coverage for painting or sanding. And a lot of times we don't really think too hard about the reachability of the robot. We're like, hey, just go try to do this giant area. And a lot of times there's some unreachable points that we can't get to, and our motion planning fails because those points are unreachable. So we started developing some algorithms and some extensions to these planners to sort of try to alleviate those problems and prune waypoints that are infeasible. We've also had some use cases where we have several different robot configurations or several different tool center points that we want to leverage. And so in the case of this video on the top, we actually had 3 different configurations of a paint gun. This is an application that we did for an ARM project last year. But we want to be able to sort of look at all these different ways that we can accomplish a task and try to synthesize sort of the best set of motions that we can to sort of achieve as much coverage as possible when we're doing motion planning. So this is sort of a library that we put together internally as a Swery internal research program. So we're still playing around with this idea. And so after we do a little bit of fine tuning, I think we're hoping to sort of push this out open source and get some documentation about how you can leverage this using some of our existing planners like OMPL and Descartes and TraJobs and wrap that into this meta planning sort of idea. So in the sphere of assembly, we've been working on a project with NIST that we're calling Contact. So the idea there is that we want to make sort of an open source framework for patching together a lot of the different elements of assembly. So I think we found that there's a lot of sort of boilerplate for getting like integrating robot controllers and sort of all this motion stuff that's involved with doing assembly. And so people who are interested in sort of doing the reinforcement learning and other algorithms for assembly actually have to spend a lot of their time sort of building up this pipeline. And so this project, the idea here is that we're going to try to put together this framework that makes it easy to sort of use different sort of robots and drivers and have that boilerplate be a framework where you can actually spend more of your time doing the development on the actual assembly learning and tasks and less of the development on this framework. So our coworker Josh Langsfeld has been putting in a lot of work to develop this framework. An idea that this is something that we're pretty excited about in terms of making sort of this connection to the ROS world and these hardware interfaces a lot more accessible, so we can spend more time doing the cool stuff that we're interested in around actually assembly tasks and learning for them. So another couple of helpful tools. This idea of kind of a region of interest selection came out of a project that we worked on a while back, and so we actually leveraged this for the demo that we did here at Automate, and ended up sort of generating a new ROS-2 harvest tool. So we find this useful for doing toolpath planning for scan and plan type applications, but the general idea is that you have some mesh shape in your workspace and you want to select a region of interest around it. We've got a couple of different methods of doing that, but something that came out recently, probably going to move this over to the ROS-Industrial work at some point, and not my own personal GitHub, but a cool tool that has been really helpful for us for toolpath planning and general scan and plan applications. Matt touched on this a little bit, but our demo here at Automate, sort of a scan and plan implementation. And like you mentioned, we made this open source with the idea that this could be sort of a template repository for bootstrapping sort of new scan and plan applications quickly. You can sort of check out what the boilerplate is and say, okay, cool, this works. Maybe try to go deploy the same idea on maybe a different set of hardware and have just something to play around with in the lab, something where you're 90% of the way there and you can tweak how it works for your own applications and sort of see how the sausage is made, so to speak. So we pushed that out. That's probably wait a week or two. Let us push our final changes to there, but definitely feel free to kick the tires on it, open some issues or discussions if you're interested in sort of pushing the development in a certain way for that. But like Matt was mentioning, it's a great tool to sort of just get introduced to scan and plan in these various tools and see how we're implementing them and the things that we're doing to make applications like that work. Yeah, sorry, I forgot to add a video. Yeah, for those of you who didn't stop by the booth, normally the way that this works is we had a couple of different arbitrarily shaped parts. We use the sensor on a robot in this new industrial reconstruction pipeline to image the part and generate a nice surface mesh representation of the part. So that's sort of what we're seeing here, is that we can generate pretty good models on parts that are traditionally really hard to reconstruct, using normal reconstruction algorithms. And so given that we have this mesh, we use the selection tool to choose an area that we're interested in doing some sort of surface processing, in this case, sort of erasing something that we've drawn on this shape, automatically generating toolpaths, and then generating a motion plan. And then using our, using our motion planning pipeline, using Descartes and TrageOps to plan motions and execute them. Yeah, so I think that sort of wraps up some of the new improvements that we've made this year. So I want to talk a little bit about ROS-1 and ROS-2 migrating and some general tips and tricks that we've been thinking about over the past year. Right, so we have a number of ongoing ports. So not all of our repositories in the ROS Industrial organization have been ported yet. We're in the progress of converting a lot of them to ROS-2. Some active ports that we have a reach study repository. In our organization, we're actively trying to port that as well. So thanks to Picnic for, I think, putting that together, helping with that. Motoman driver is currently being ported as well. We did a lot of work on that. We're hoping to use that at the Automate demo, but didn't quite get there. That's an ongoing effort that should be wrapped up here pretty soon, so we're excited about that. active ports as well. Tesseract with ROS-2 not only has sort of an interface there, but it's sort of an ongoing port to expose all of those cool functionality of Tesseract in ROS-2 environment. And our toolpath planning library as well. And we're going through sort of a reorganization of that library to make it a lot easier to port and work on that port as well. So I think we hear a lot about supporting legacy ROS-1 systems. So I wanted to touch on that a little bit because I think that's sort of a concern for a lot of people who build these systems and deploy them. Like what happens when ROS-1 is no longer supported. So just sort of as a information here, the end of life for Melodic is in 2023 and the end of life for Noetic is in 2025. So we still have a little bit of time, right, before these systems get end of life. But not only, it doesn't necessarily mean that they will cease to exist after that point, they just won't get active bug fixes and in development. So they'll still be around, they'll still be usable. So what I want to point out as well is that a lot of these ROS-1 packages are being hosted on Conda. And so there's an organization, I think it's QuantStack, that's sort of managing the deployment of ROS-1 stack and putting it on Conda. So I think that's sort of a vision for how ROS-1 is going to be sort of supported after end of life is through this Conda package manager. So we've done a little bit of experimentation with downloading ROS-1 from there. That's definitely something to check out for the future to continue supporting ROS-1 for things that have already been deployed. And then obviously the source code is open source. So like worst case scenario, you can always build these different ROS distributions from source. But it's probably not the preferred method, but definitely still available. And migration strategies, right? You know, ROS-2 has come a long ways. There's a lot of great documentation out there. And I would say for things that you guys are thinking about developing from scratch and starting, definitely start in ROS-2. I think it's definitely at that level where you can develop in ROS-2 very easily. And there's lots of documentation and support. So some things that we found for our own internal tools that have been really helpful for us to start porting from ROS-1 to ROS-2 is trying to distinguish between the elements of the code that really need the ROS interface and the elements of the code that are maybe core and sort of independent of ROS. And so we've been trying to reorganize a lot of our code to sort of have the core piece be sort of pure CMake or ROS independent, and then writing ROS wrappers to sort of sit on top. That way we can support ROS-1, ROS-2 fairly easily. Then we can also take some of these core tools and deploy them on platforms that are even ROS independent. And so that's seemed to work really well for us. It's sort of kind of an architectural change, but like I said, it's a strategy that we've been using that's been pretty helpful for us to really minimize the amount of things that we have to change when we want to pull something from ROS-1 to ROS-2. We also have some, this last bullet point here, some tools for doing sort of pure CMake builds a little bit more easily. Levi has done a lot of work on that package for writing macros and CMake that really sort of reduce the burden on end user for sort of building out your CMake list. So on to some usability improvements. You know, we get a lot of comments, right, that, you know, we don't want to necessarily be advanced programmers to have to use all these tools. So we're trying to think a lot about how do we make them more accessible to people without a strong programming background. So some improvements that have come out this year have been, you know, around this toolpath planning library. So not only we have a lot of cool functionality there for generating toolpaths on arbitrary meshes and sort of modifying them and for motion planning. And so something that we put together as a part of our Automate demo this year is sort of a GUI to more easily support sort of the configuration of the toolpath planning pipeline. And so we've been going through a little bit of a redesign on this library to make it more modular and support sort of a ROS-2, ROS-1 interface as well. And so what we're showing off here is that we have sort of a GUI that can dynamically load different types of toolpath planners and modifiers. And we can go through there and sort of interactively change how we generate toolpaths to let you guys sort of experiment around a little bit and see, change the way that toolpaths are generated. And that's been really helpful for us on, you know, sort of this demo that we were doing today, or doing this week at Automate to support different types of motion planning. So I think these are the sort of things that we're looking for is, you know, how do we expose these tools via GUI and make them, you know, more accessible and, you know, require a lot less sort of building of code and writing of code to be able to use. So in that same vein, I think we've gotten a lot of feedback in the past about wanting to use a lot of these ROS tools in the context of a CAD environment and using them, you know, in a way where we don't have to write really any code. So internally at Swery, we've been developing this tool to leverage our ROS capabilities inside of a FreeCAD environment. So we put together this application so far, and I think we'll do a little bit more discussion later on about sort of features and improvement. But we wanted to share a little bit of the work that we've been doing here. So some current capabilities that we've created for these videos is just the ability to create and export URDFs and robot models. So not only that's what the video on the top is showing, it's like, okay, we've got a spec sheet for an ABB robot open, and we're importing the CAD geometry and sort of building up our URDF in this FreeCAD environment. We can export that to URDF to use for some of our other robotic systems. So along the same lines, right, we typically generate convex holes for collision models, and so that's something that we built into this tool as well. Right, you bring in your visual geometry, you click a button, automatically generate convex holes for your collision models, and all that's sort of self-contained in this GUI CAD-based environment. Similarly, we've integrated kinematics capabilities here as well. So you build up your robot, and then you can choose from different IK solvers and actually be able to sort of drag the robot around, verify kinematics, make sure everything's sort of moving as we expect. And then on the planning side, right, this is the video on the bottom. We've integrated the ability to define waypoints and sort of build out a rough trajectory, and then actually integrate some of our motion planning tools like OMPL and Descartes, TraJobs, and define custom planning pipelines in this sort of GUI-based environment and generate motion plans inside of FreeCAD. And again, with the idea that not only we can do all of our planning, we can do some of our toolpath planning here as well, sort of use this CAD-based environment as a way to generate robot programs offline. And sort of for us internally, using it to be able to experiment with different planning pipelines, different approaches for planning. So our idea for sort of future development, right, is obviously we want to be able to use these trajectories right now. We can really only visualize them, but we want to export those robot trajectories that we're planning in this environment to meaningful deployable formats, right? Being able to write FANUC programs and motivate programs and ABB programs and actually spit those out to a robot controller and execute the thing we planned, or stream them via ROS driver as well. And then again, sort of integrating these tools for toolpath planning, leveraging sort of the CAD environment to be able to define toolpaths on actual CAD geometry that we bring in. So I think we'll focus on sort of the next couple of months. Again, yeah, we're also looking to make this cross-platform, so that's why we chose the FreeCAD environment. So built on Windows and Linux, right? Just try to support as many users as possible. So anyway, I think we'll discuss this a little bit more in the future, but I think later today, this meeting, but we're definitely looking for feedback on sort of, hey, is this idea sort of align with your use cases? Is this missing some features that are really important? So this is right now, it's pretty much, it's really in its infancy. So we're looking for a lot of feedback from you guys on what makes sense. Yeah, so looking forward, some things that I personally am interested in sort of doing this next year is refactoring our calibration library, providing those usability improvements and sort of GUI interfaces there. It's something that we use all the time and almost always involves a lot of coding. So I think we can do a lot of work there. Another thing that I'm sort of interested in is providing Python bindings for a lot of our tools. So personally, I think that would really help lower the barrier of entry to using a lot of these tools. Just make them a lot more accessible, and I think there's a lot of examples and libraries out there for doing that. So it's something I'm really interested in trying out. And again, with ROS-2 being able to build on Windows, trying to look at our repositories and actually get them building on Windows, having CI builds and making them accessible for builds on Windows. So you don't necessarily have to go do a Linux install to be able to use all these cool tools. With that, I think I'm pretty close out of time, but happy to answer any questions if you guys have comments.
Yeah, one question.
Good. Sure, yeah. So I think the question is the industrial reconstruction repository real and is it open source? I think nominally right now it's probably not real. I think that link is not there, but we will be pushing it out within the week. I think it's on Tyler's personal fork right now, sort of as a development thing, but I think it's pretty cleaned up and ready to go. So I think within the week, you should see it out on the ROS-Industrial organization. I'm sure we'll make Twitter posts about it and maybe blog posts as well.
Members. First off, a question about
Yeah.
what bench? What collision meshes for this SolidWorks Korea Explorer? There you have the problem that basic collision meshes that we generate are.
Yeah.
Do you have a solution for that? Workbench also for example, expanding the collision meshes.
Yeah. So I think the question for online is, in this FreeCAD environment, we have a way of generating collision meshes that have less detail, and then do we have some control over sort of expanding them to make them more generous for collision checking? So yes, we do have a tool that's built into this FreeCAD environment for generating convex holes of meshes. We also have a tool for doing convex decomposition. So I don't know if you guys maybe experimented with making convex holes. If you got a weird shaped part that's not really convex, then your convex hole ends up being really, really huge and not exactly usable for collision checking. And so that's where this convex decomposition library comes in. We can talk a little bit more about it offline later, but basically you can decompose your shape into a lot of smaller convex holes. And so we've been leveraging that quite a bit for generating convex holes for complicated shapes, and it works reasonably well with some tuning. I think what we don't necessarily have right now is something to expand those convex holes like we were talking about, but I think that's something that we could probably build in relatively easily, and that's sort of an important piece, right? Like you don't want your collision models to be exactly the same as your visual models, and just sort of a little bit of a buffer in there. So that's great feedback.
All right, thanks. Mike will be around. Obviously, we're going to have a workshop and talk a little about these tools. So Jeremy's also going to be back. He's actually a PM our here. We have one here, so feel free to code. And that's a good